This is Daniel Tamayo. I'll be presenting the Space Shuttle Challenger explosion for MEC111. This disaster refers to the devastating explosion of the 1986 Space Shuttle launch that killed all of its crew members just moments after the launch. This disaster resulted in a 32-month shutdown of the Space Shuttle program for NASA, and it was used to further investigate what had been the cause of the disaster, as well as to salvage parts from the wreckage. For some context, a space shuttle consists of three main components. First is the external tank, or the ET. It's the massive orange container in the middle that holds all the fuel for takeoff. It's comprised of two main components, the container for the liquid hydrogen fuel and then one for the liquid oxygen fuel. The two rockets on the side are the solid rocket boosters, or the SRBs. They provide the necessary thrust for liftoff and burn a majority of the fuel from the ET itself. Once the fuel is expended, the ET and SRBs detach from the orbiter. And lastly, the orbiter is the space shuttle that carries the crew and the payload. It's designed as a reusable spacecraft that can fly and land on Earth. A brief history on the spacecraft itself. It was originally an SDA-099 craft, or a structural test article craft, that was built in 1978. It was designed as a low-orbit craft that could also be converted into a flight vehicle if it was necessary. During its lifetime, it performed several commercial and military payload missions, such as deploying satellites and other scientific tools in space. In 1979, NASA had plans to create a more lightweight and space-rated orbiter. The plan originally was to retrofit an already existing orbiter, the Space Shuttle Enterprise, designation OV-101, but after further consultation, it was found that rebuilding SDA-099 into an orbiter would be considerably cheaper. The conversion was finished in 1981, and the new orbiter was given the designation OV-099, and the official name Challenger was given. The finished craft was considerably lighter compared to the other spacefaring crafts and could carry almost 2,500 pounds of extra cargo and payload. The Challenger shuttle made its debut flight in 1983, deploying the first satellite for tracking and data relay system constellation. The last mission of the Challenger space shuttle was designation mission STS-51-L. The initial announcement of the launch was made in January 1985, where the 7 crew members and the launch date was given. The mission was to deploy a tracking and data relay satellite, or a TDRS. This was to enable constant communications between orbiting spacecraft. The crew were also set to study the Halley's Comet as it passed the Sun. The original date of the mission was to be in July 1985, but was delayed to November of the same year, then was delayed again to January of 1986, where the date was supposed to be on the 22nd, but the final delay was set to January 28, 1986. On the morning of the launch, record low temperatures had worried the engineers for the safety of the launch, so much so that the ice had started to form on the shuttle and other NASA buildings. There were previous tests conducted to check for O-ring erosion and joint integrity of the SRBs, but they were tested at temperature ranges of 40 to 90 degrees Fahrenheit or 4 to 32 degrees Celsius. The temperatures that were recorded on the morning of the launch were around 18 degrees Fahrenheit or negative 8 degrees Celsius. The engineers were concerned that the low temperatures would affect the elasticity of the rubber, and they were not sure whether the low temperatures could compromise the seal, as the engineers had no conclusive data if the O-rings would even seal at such low temperatures. The engineers voiced their concerns to their supervisors, and a meeting was held between the engineers and the management team to discuss the safety concerns they had. Once the meeting had finished, management concluded that the data presented was inconclusive and that there would be enough margin of error to cover for an O-ring failure. So with approval from their supervisors, the launch was scheduled to proceed. Here's a clip of the Challenger launch, and a few seconds after the launch, a plume of smoke could be seen forming on the right solid rocket booster, and then a few seconds after that, the shuttle erupts into flames and then explodes soon after. right there. And here you can see the rocket boosters and the rest of the shuttle splitting as it exploded. The Roger Commission was appointed by the president to investigate what had been the cause of the failure. Testings later confirmed that the concerns of the engineers were correct and that the low temperatures resulted in an O-ring failure. The low temperatures caused the O-ring gaskets to shrink, resulting in hot gases leaking into the field joint. Hot gases melted through the metal struts and caused the right SRB to shift violently. The violent movement ruptured the ET, which leaked fuel, which then ignited and exploded. Other speculations that the commission had was that the crew may have survived the initial explosion, but were killed as the orbiter impacted the ocean. The commission also speculated that the mounting pressures from multiple launch delays may have affected the decision-making of management to clear the launch. There was continued growth of media coverage leading up to the launch, and the decision may have been done to save face for the moment. The Challenger disaster resulted in several case studies for engineering ethics, communication, and safety. Regarding engineering ethics itself, there was a definitive failure in safety protocols by NASA. The lack of conclusive evidence that the engineers had for their concerns were not readily available, and management had not given the engineers time to test for the conditions that were given to them. Regarding communications, of course, there was a report by the commission of an overcomplicated explanation by the engineers, as well as just poor communication between the two parties. Management had severely underestimated the margin of error for failure of the O-rings, and there was no consultation with quality assurance at the time. Regarding the safety culture and management structure of NASA was under severe scrutiny, and management found that it required much needed reforms. To combat what had happened, the commission provided several recommendations of improvement. The first was to redesign the solid rocket boosters. In the new design, a secondary O-ring was installed in case one were to fail. Heaters were also installed to maintain the ideal temperatures for the O-rings, and they also redesigned the field joint to prevent and reduce the effects of joint rotation. The space shuttle was improved in terms of their steering and maneuverability, primarily for the descent, and they also included a escape hatch on the side for crew members in case of an emergency. Astronauts were given improved spacesuits with a deployable parachute, and because of the incident, they also halted all civilians to be able to board a space shuttle for almost 20 years. The last recommendation was to create the Office of Safety, Reliability, and Quality Assurance within NASA. To conclude, the Challenger disaster was a result of several management errors from NASA, starting from the lack of testing of the O-rings at lower temperatures, the decision of management to proceed with the launch despite the lack of evidence to support their margin of error, and also to launch to save face from the multiple launch delays. If safety protocols had been properly followed, then the launch should have been delayed until temperatures were ideal. The resulting disaster helped to improve the overall safety standards of NASA by the restructuring of NASA's management, creation of a proper safety and quality assurance office, and the redesign of the rocket boosters and space shuttles helped to ensure that a similar disaster would not happen again.